Hello and welcome to Lab 2, Lines of Charge. So some introduction before we begin. The purpose of this lab is to repeat the same exact experiment from Lab 1, but now we're changing the point charge model to the lines of charge model. So lines of charge model is created by dividing the tape into multiple sections as point charges, as opposed to taking the entire piece of tape as a singular point charge. So some key concepts and fundamentals that we need to know are Coulomb's law, which is the electric force, the gravitational force, and Newton's second law. Some assumptions we made were that there were no air resistance acting on the tapes, and that each tape created has the same charge and is distributed evenly throughout. The main results that we achieved today are that the magnitude of charge on one piece of tape is equal to 2.766 times 10 to the negative 8th coulombs. So this is a very different result from Lab 1, and we'll talk why later in the lab. As for the experiment, it's the same exact as Lab 1. So our system is tape A, tape B, our surroundings are everything else. Our initial conditions is that everything is neutral. And the process was that tape B was stuck onto another piece of tape and then ripped off to create a positive charge because it's losing electrons. It was declared positive after seeing it become attracted to my hand, which is a negative charge since opposite charges attract. And then we noticed that when it was approached with tape A, tape B appeared to levitate due to repulsion since like charges repel. Here is the computational model that we made, but instead of a point charge, we used lines of charges. So our physical constants are the same, the mass of the tape is the same, the length, the distance is the same. Here is our estimated net charge, which is the main result for today. This piece of code created our electric field, and then this piece of code is what created our lines of charge. This is what differs from Lab 1. Here we have the two tapes, we created them, and then we scaled the electric field, as well as created arrows for the electric force and the gravitational, which should cancel out in the end. It'll look like that, with that being the tape. And then here again, we have more of the electric and gravitational forces, and then the arrows at the very end. And here is the result. So we have our gravitational force going downward and our electric force going upward, and this is all the little lines of charge. These are all little arrows like that. And you can see here that our magnitude of our electric and gravitational force is are basically equivalent, which is what we wanted. So comparing this model and the real-life experiment, there are still some discrepancies. The gravitational and electric force are not exactly equal. There's a slight discrepancy, but they basically are. And then the tape was divided into finite segments instead of infinitesimally small segments, so it's still not 100% accurate. The computational model, again, is simulated in a perfect world and with perfect numbers, and the real-life experiment occurred under non-perfect or ideal conditions. However, in the end, this model is much closer to the real experiment than Lab 1 in regards to accuracy. Some last questions include, what if you had modeled each of your tapes as a single point charge, like in the previous lab? So last lab, we estimated that this is the charge, 1.43 times 10 to the negative 8th coulombs, and you can see how different it is to Lab 2. It's still in the same order of magnitude, but 2.766 is different from 1.33 or 1.30. So the point charge model was very inaccurate as opposed to the lines of charge model, and the gravitational and electrical force did not equal each other in the point charge model, whereas they were very close in the lines of charge model to cancel each other out. So why do these estimates differ? It's because different models were used. We used one as a point charge and one as a lines of charge. And the lines of charge model is much closer to the real value because it actually takes into account that the tape will have differing areas of charges and that it's not one singular point charge. So some conclusions. Our possible sources of error in the lab include that we assumed air resistance was negligible. The pieces of tape may have had differing charges, but were assumed to be equal, and they were also assumed to have equally distributed charges, which may not have been true, and also mishandling of the tape could have caused charge discrepancies. So the main results and takeaways of this lab is that breaking the tape into smaller point charges was more accurate than lab 1, and if we continue dividing the tape into infinitesimally small point charges, the results will only get more accurate, and that the point charge models are inappropriate when measuring a macro scale object. Thanks for watching.